Okay, lower sixth. I just want us to look quickly at improper fractions for a second. Can you spot the improper fractions? 1.5. Okay. Which of these is improper? Well, first one's proper because it's got a smaller number over a bigger number. And the other two are both improper, since the numerator is greater than the denominator. Now, when we're looking at algebraic fractions, we don't have numbers to compare in the same way, but we do have something called the order. Now, for a polynomial, the order is the power, the highest power of x. So we consider the order of the top and the bottom, and we use that to decide whether our fraction is improper or not. So we can see the first one is a proper fraction because the top is a lower order than the bottom one. Okay, so the first one is a proper fraction. The last one we can see is clearly improper because the order is so big at the top and only 17 at the bottom. However, what do we get when we have the order is the same on the top and bottom? There's no real equivalent with fractions. That's just equal to 1. So the same order is improper. I want that to be in your notes. If the order at the top and the bottom is the same, then it's improper. Okay, a couple of examples for us to go through. It's the method required when converting improper fractions into partial fractions. First of all, we have to identify that we have an improper fraction. You need to do this alone. No one's going to warn you or tell you what to do here. You need to identify it at the beginning or you won't get marks for the question. Okay, so it's obviously from the big fuss I'm making about it, it's an issue that people come across quite frequently, is not to spot the order of the polynomials. So we're imagining the x squared in the denominator. Now, once we've got this, we're going to expand the denominator. That's what we get when we expand and gather the two middle terms. And we're going to actually do the division. We're going to divide the top thing by the bottom thing of our fraction. So we write in our polynomials and we're going to do our division. So we're going to go through this. We're dividing x cubed by x squared to get x. We then multiply x by the entire original polynomial and write it down underneath. And then we subtract. Now when we subtract, we want our x cubed terms to cancel, which they do. And then we get a quadratic underneath. We multiply, we do our division. We're dividing 6x squared by x squared, gives us 6. Multiplying through by 6 gives us the quadratic that you'll see appearing on the screen. And the final step is to do the subtraction. 15x plus 20. Okay, so we can rewrite the original fraction as x plus 6. Plus the remainder, which is still to be divided by the denominator. Now, the only thing we've got left is an improper fraction, and that's the key. We have turned this from a question with an improper fraction into one with a proper fraction now. So we're going to focus on the proper fraction, and we're going to split that into partial fractions. So it's exactly the same trick as last time. We use capital A and capital B with each of the factors as our two denominators. We're going to multiply through by both of those factors to remove the entire denominator from the left-hand side, leaving us with the numerator 5x plus 20. And the two numerators on the other side, each multiplied by the opposite denominator. If we put x equals 3 into the equation, we remove a, and we're left with our value for b, 35 over 4. And if we substitute x equals minus 1 in, we remove b from our equation, and we get 15 is equal to minus 4a. Okay, now we found our values for a and b. We can put them back into the red algebra at the top of the screen, which is going to replace the original fraction on the top left. So you'll notice I'm putting the numerators of a and b in the numerators of the fraction, and I can put the denominators in the denominators with brackets separating them from the other factors. And we're done. Okay, so I wanted to do an example with an improper fraction with repeated roots. It's perhaps the most difficult type example. This is quite a big, long task, so have a lot of space available. Try and lay out your work a bit better than I do in this video. So we start by expanding the brackets at the bottom, and we're going to do the division that we've done at the start with each improper fraction. So if we expand our bracket completely, 3 brackets is quite a bit to do. We're just left to add the terms here. X cubed minus 3x squared plus 4. That's the thing we're dividing by because it's the denominator. So we're going to divide x to the power 4 by it. So as we go through, you can see on the board the working out that is involved by doing algebraic division. So we're left with a 3x cubed term, which we're going to divide by x cubed, and that'll give us 3. We then multiply by 3, and we'll be doing the subtraction step. Make sure you're leaving gaps when you do your division, so that you have a column for x squareds and x's, space to work. Now we're doing the subtraction here. So it's the top take away the bottom, which is why we see a sign change with the 9. Okay, so now we have got rid of the improper aspect. We have a quadratic at the top, quite a nasty looking thing, and we return our denominator to its factorised form, and we're about to focus all our attention on that new fraction. Okay, this new fraction, it is a proper fraction. The top order is less than the bottom order. We're going to do x plus 1 as a denominator, x minus 2 as a denominator, and x minus 2 squared as a denominator. We're going to expand through, multiply through by the denominator on the left-hand side, leaving us just this quadratic on the top. And factors around a, b, and c as follows. We then play the usual trick by setting x to the values which zero out each of the bracketed factors. Gives us our value for c. And our value for a. Now we look at the x squared coefficient to see if we can find out the value of c. Now if I look at the x squared coefficients in each of the three terms on my right hand side, I get ax squared, bx squared, and there's no x squared in the final term. So a and b give me the coefficient of x squared, which is 9. So 9 equals a plus b is what we're using. We find out our value for b as 83 over 9. We do a quick check, which you'll see run out on the screen. There we go. So we've found our values of a, b, and c. And we put those back in to the working we've done already. Remember, we've got the x plus 3, which appears here. And then the fraction has been converted into this red form here. And each of the constant values has its numerator appear in the numerator and denominator in the denominator, making sure we get the signs correct as well, so they're negative there. Okay, that's finished. Now move on to the questions. Okay, pause the video and have a go. The solution will be coming up shortly, so you need to pause. Okay, pause the video and have a go at this question. Make sure you write out what you see to start with. Okay, pause the video and have a go at this question. Okay, this is a cheeky little question. I want you to pause it, have a go at it. I wonder if you spot what you need to do. Have a go, pause, pause, pause. pause and have a go at the question. Okay, pause the video. This is quite a big one, so you'll need lots of space. Pause the video and have a go. You know what to do by now. Pause, and have a go.